Hi, my name is Vance Peterson, and this is the ENGR3501 final project. For this project, I built a Geiger counter using plans I found on a YouTube video. It seemed like a pretty straightforward design. It ended up being a little bit more complicated than I would have hoped. I feel, though, that I learned much more from it than I would have ever expected. It started with, based around using an SBM20 I purchased on Amazon that will detect beta particles and gamma rays. Originally, the design was supposed to use a 3.7 volt lithium-ion battery. I'll explain later I ended up going away from that and using just an external 5 volt power supply to simplify it. Everything that I ordered from this I got from either Amazon or from Micro Center in Marietta. For the assembly of it, I used a 3D printed case with the plans from the project, an Arduino Nano to control it, the SBM20 Geiger tube. I used a step-up board, originally with the first design, to step up the 3.7 volts from the lithium-ion battery to the 5 that's needed to run the Arduino. Same thing with the charging board. This would have allowed USB-C charging and monitoring of the lithium battery. I ran out of some space issues inside the case, which is why that got scrapped. The LM2596 buck converter, this takes anywhere, I believe, from 1.5 to 24 volts DC and can step it up to 600 volts DC, which is needed to run the Geiger tube. I was able to put a multimeter on that, apply 5 volts, and tune it to the 400 that I needed. There's a 10K and 10 mega ohm resistor that are in use. The 10K resistors are used for a transistor circuit that comes off the negative side of the Geiger tube, where the 10 mega ohm resistor is on the positive side coming from the 400 volt source. 470 picofarad capacitor in the transistor circuit as well. The 2N3904 transistor is included in that. The original design was a 128 by 64 OLED display. Just for space and time and cost, I cut that in half and went down to a 32 pixel tall OLED display, and I added a piezo buzzer as well to complement what was shown on the OLED. So here's a diagram of the build, and as you can see, there is a 400 volt power supply that's taking 5 volts and stepping up to 400. It's very low amperage, and there's the 10 mega ohm resistor. We've got the transistor circuit coming off the negative leg of the 400 volt power supply, going down to the ground on the Nano, as well as the piezo speaker that's hooked up to the D7 pin. The OLED is simply powered by switch power on, common ground, and a data and a clock signal coming from the Arduino. And the lithium diagram on the right ended up being replaced with a slightly modified version, again to use 5 volt external power rather than an onboard lithium battery. So the 3D printing was pretty straightforward. It's probably the easiest part of this project. I had the file. It ended up needing to be tweaked a little bit. The first one that I printed, the Geiger tube would not fit. It was too long, and the ends that would be soldered on did not fit. And it was supposed to be a press fit, I believe, and it didn't go through. So what I did is I bumped the dimensions up by 2% and printed 102% of its original size, and that fixed most of the fitment issues that I had. Everything else could be fixed with either a pair of flush cut tweezers or a file. So for the coding, this was a little tricky. As you can see, there is some Russian in it. I could make out most of the comments, and the helpful part is that the language is exactly what it would be for any other project, minus the comments. So the pins that were supposed to be used for some of these would have worked without issue until it goes to putting it in the case. The original design, he was using basically what would be the cabling and the wiring inside of an Ethernet cable, very small gauge. I did not have any. I used what was left over from an Arduino kit. It was a bigger gauge, the insulation was thicker, and I ran out of room very fast. So what I did is I went through and I figured which pins would work best, and simply change the pin layout in the program to go along with the new pin layout. There was also an issue with the battery indication where with a full 3.7 volt battery, the battery indicator was not reading full and it was too responsive. Where if the battery were to be on the edge of 1 bar, let's say four full bars and three full bars, it would bounce back and forth as the battery voltage changed. There was no dampening to it. So I adjusted that so that way it would behave more like the fuel gauge in your car. It'd be a little bit smoother. When it came to the assembly, it's pretty straightforward. On the bench, just soldering in the wires that I knew I needed onto the Arduino, hooking them up to the OLED, and testing to make sure it would boot up correctly. There were no power issues with it being over or under powered, and the solder joints were all good. And there is the display. You can see the battery indicator is, since there's not a battery hooked up to the voltage pin, it does not know what the state of the battery is, hence the odd indication we're getting there. So there's two step-up converters in this. The original one from the 3.7 volt battery to the board on the Arduino, that was 3.7 volts up to 5, and everything in this case needed 5 volts. Once we went away from that, I scrapped it, went straight to USB into it, made it much easier. I wasn't running out of room in the case, and I probably should have done that from the get-go for this. The second step-up converter is the larger one you see there, the blue. That takes the 5 volts in. You adjust the potentiometer to get the 400 volts out that you need. I just tied the ground from the 400 volt output back to the ground on the board, again because we've got one common ground in this entire case. You can see in the bottom left-hand corner of the picture there's a big clump of resistors. I will explain that, as well as the capacitors that have been stacked up in the bottom of the picture there in the transistor circuit. That was not planned, and unfortunately we had to do it because of my Amazon purchases. So here's the issues we had with it. It was originally the capacitors that I ordered were supposed to be including a 470 picofarad capacitor. That did not happen. I ordered the wrong ones. So what I did was I took two 220 picofarad capacitors and a 30 picofarad, put them in parallel. That gives us the 470 that we need. Soldering was a little bit tricky with this because there were so many of them, but it worked just fine. Same thing with the resistors. I thought I had ordered a 10 mega ohm resistor, which I just needed the one on the 400 volt side of the Geiger tube, and I didn't. I ordered 1 mega ohm. So I soldered the 10 1 mega ohm resistors in series and gave me the 10 mega ohms I needed. So the 18650 battery that was supposed to go in it originally had issues with the fitment in it. The one for the original project was a flat top. It did not have a protective circuit in it, so it fit in the case. The one that I got, the only one I could find in the store, had the PCB on the top of it, makes it a little bit taller, and it doesn't fit. So instead of redesigning the case, I scrapped it all together. I saved room by taking out the charging board as well, and really opened things up and made it a little bit easier to work on just by going with an external power source. And so here is the final product. There are some issues with layer adhesion on the 3D print. It's somewhat irrelevant for this, but overall I'm quite happy with it. I have tested it around the house. I've had some success, but nothing that really sets me off to think. A little questioning of the accuracy of it. And hopefully I'll find out just how accurate it is once we go to the lab. Thank you.